The hollow Earth theory. What if Earth wasn't solid, but hollow? That's what some scientists and explorers believed between the 17th and 19th centuries. The hollow Earth theory claimed the planet had layers, like a Russian doll, with massive inner worlds and even entire civilizations hidden below. Even Edmund Halley, yes, the comet guy, proposed this idea. He imagined concentric inner shells, each possibly supporting life. He even suggested that the northern lights were sunlight leaking from the inner Earth. Writers like Jules Verne loved it too, inspiring Journey to the Center of the Earth. Of course, we now know Earth has a solid inner core and molten outer layers. But oddly enough, Halley's theory encouraged early ideas about planetary structure and seismology. The phlogiston theory. Before we understood oxygen, people had a different idea of how things burned. The phlogiston theory from the 1600s said that flammable objects contained a substance called phlogiston. When something burned, it wasn't destroyed, it just released its phlogiston into the air. This explained why burning left ash. The object had lost all its phlogiston. Fire stopped when the air became too full of it. The theory made sense, until chemistry advanced. Joseph Priestley even discovered oxygen but still believed in phlogiston. It took Antoine Lavoisier to disprove it. He showed that burning was caused by combining with oxygen, not losing anything. Still, the phlogiston theory helped spark early chemical experiments and led to modern chemistry. Wrong idea, right direction. Ether theory. In the 1800s, scientists believed light needed something to travel through, just like sound needs air. So they imagined the luminiferous ether, an invisible substance filling space. If ether was real, Earth would be moving through it, creating an ether wind, like a boat sailing through water. To detect this, physicists built experiments, most famously the Michelson-Morley experiment in 1887. But they found nothing. No wind, no shift, no proof of ether. This failure was a turning point. It helped disprove the theory and set the stage for Einstein's theory of relativity, which showed that light travels through a vacuum without needing a medium. So while the ether didn't exist, chasing it helped unlock one of science's biggest breakthroughs, the miasma theory. For centuries, people thought diseases came from miasma, foul, poisonous air. Plagues, cholera, and other outbreaks were blamed on bad smells, especially in dirty cities. And while the theory was wrong, it led to something surprisingly useful: better sanitation. To fight miasma, governments cleaned streets, drained swamps, and built sewage systems, not because of germs, but to get rid of the stink. Then came John Snow, who traced a cholera outbreak to a water pump, proving it wasn't air, but contaminated water. Pasteur and Koch later confirmed that germs, not gases, caused disease. Miasma theory was false, but it pushed society to build cleaner, safer cities before germ theory was widely accepted. Spontaneous generation. Long ago, people believed that life could appear from non-living matter. This was spontaneous generation, the idea that mice came from grain or flies from rotting meat. Even Aristotle believed it. In the 1600s, Francesco Redi challenged this by showing maggots only appeared when flies laid eggs, but many still clung to the theory. Then came Louis Pasteur. He boiled broth in special flasks, sealed them, and proved that life didn't appear unless microbes entered from the air. This experiment crushed the idea of spontaneous generation and gave rise to germ theory. While completely wrong, this theory led scientists to ask, where does life come from? That question still echoes in biology today. The geocentric model. For centuries, people believed Earth was the center of everything. The geocentric model backed by Ptolemy showed the sun, moon, and planets all orbiting Earth in perfect circles. It explained the sky, sort of, but needed messy fixes like loops and epicycles to explain strange motions. Then Copernicus proposed the heliocentric model, the sun at the center. Galileo's telescope backed it up, and Kepler showed that orbits were elliptical, not circular. Eventually, the geocentric model was dropped, but it had dominated for over 1,000 years. It was wrong, but it inspired centuries of skywatching, math, and mapping. Sometimes science moves forward even when it's stuck in the wrong place. Which one surprised you most? Let us know in the comments.